Welcome to episode 2, where things get real. Because we're not talking about chatbots anymore. We're talking about AI agents, systems that can actually do things. Book a flight, move money, update a database, open a ticket, trigger a workflow. And here's the thing, the moment your AI can take actions, a wrong answer isn't just embarrassing, it's expensive, it's a refund that shouldn't have happened, a record that got changed, a workflow that fired when it shouldn't have. So today I want to walk you through how you actually architect quality for these kinds of systems where there's no fixed UI. The system is choosing its own path, and your job is to prove it's safe to run. Here's what we're covering in this episode. How to test autonomy, meaning how do you validate a system that's deciding its own steps? The state management problems that cause agents to spiral, loop, or go completely off the rails, integration testing 2.0, how to test the handoff between an LLM and your legacy API, and the leadership shift. How do you design a quality strategy when there's no stable UI to anchor your testing to? Before we get into it, two quick definitions because I want us to be speaking the same language. First, an LLM or large language model is a system trained on massive amounts of text and code. It generates outputs by predicting the next token, basically the next word or piece of code. And the important thing to know is that it can sound completely confident even when it's wrong. Second, an AI agent. And this is the one that really matters for this episode. An agent is what you get when you take that LLM and connect it to tools. So it can actually do things, not just talk about them. Basically, an agent is LLM plus tool access. And then an agentic workflow is when that agent runs a multi-step loop, plan something, take an action, check the results, adjust, and repeat. And that's exactly where QA gets harder because now we're not testing a single response. We're testing a whole chain of decisions plus the side effects of every action along the way. All right, let's talk about key concepts. Let's start with autonomy. In classic test automation, you're the one choosing the path. Click this, verify that, assert the output. With an agent, the system is choosing the path. Which tool to use? What order to do things in when it decides it's done? So how do you test something that's making its own decisions? You stop trying to lock down the exact steps it takes and you start testing boundaries, invariants, and allowed actions. Now, what are invariants? An invariant is just a rule that must always be true, no matter what route the agent takes to get there. So let's say you've got an agent that can issue refunds. Your invariants might look like never refund over a certain dollar amount without human approval, never refund to a different account than the original payment method, always log the reason and the evidence the agent used to make that decision. That's it. You're not scripting every step, you're defining the boundaries it has to stay inside. And those boundaries, those constraints, that's what we call guardrails. Guardrails are things like permissions, allow lists, rate limits, approval steps, anything that keeps the agent from doing something unsafe, even when it genuinely thinks is being helpful. So in practice, here's what your test approach looks like for autonomy. Action allow list tests. Verify the agent can only call the tools and endpoints it's supposed to. Permission boundary test, verify it can't escalate its own access or do things outside its role. Policy test, verify it refuses actions that violate policy even if someone pushes it hard. Stop behavior test, verify it knows when to stop and hand off to a human, especially when confidence is low or the impact is high. Autonomy testing isn't did it follow the exact steps I imagined. It's did it stay inside the boundary and produce safe outcomes. That's the shift. Now, let's talk key concept number 2, state management in AI, avoid loops plus runaway behavior. Let's talk about the thing that breaks a lot of agent demos the moment they hit production. State. State is basically what the agent remembers about what it's already done, its plan, its progress, the results it got from tools, and where it currently is in the task. When state is managed poorly, agents get into real trouble. They repeat the same action over and over. They retry failures indefinitely. They lose track of what's already happened, or they start inventing facts to fill in the gaps. And that last one leads to what people call a hallucination loop. A hallucination, just to define it quickly, is when the model produces something that sounds correct but isn't actually grounded in real data or real tool results. It's confident, it's fluent, it's just wrong. So, a hallucination loop is when the agent keeps generating confident next steps based on made up assumptions. And because it has tool access, it can actually turn those assumptions into real actions in the real world. That's where it gets dangerous. Here's how you test state management, and none of this requires you to rebuild the system. Step budget tests give the agent a maximum number of steps it's allowed to take and verify it stops cleanly, produces a summary, and hands off properly when it hits that limit. Retry policy tests simulate a flaky dependency and verify the agent does bounded retries, backs off appropriately, and then escalates instead of looping forever. Idempotency tests, if the agent calls the same tool twice, make sure the system doesn't double charge, double book, or double update. Idempotent just means running the same operation twice doesn't create extra side effects. It's a property you want to verify is actually there. Grounding checks require the agent to cite the actual tool output or retrieved source it used before it's allowed to take a high impact action. And this is where quality leaders ask a different question than everyone else. Not how do we prevent all failures, but what is our safe failure mode? What does a graceful stop look like? That's the question that separates execution from leadership. Next up, integration testing. And I'm calling it 2.0 because the old version doesn't cover what we need anymore. In agentic systems, the most dangerous bugs live at the handoffs. The LLM decides to call a tool. The tool hits an API. The API returns something unexpected. The agent misinterprets it and does something it shouldn't. So, integration testing 2.0 is about testing the conversation between the agent and the system, not just the system in isolations. Here's what to test at this layer. 1, schema and parameter validation. Wrong data types, missing required fields, out of range values, injection style strings in parameters. 2, error interpretation tests. How does the agent handle different error response codes? 401 versus a 403 versus a 429 versus a 500. What happens on a timeout? What happens on a partial success response? You want to verify it does the right thing in each case, retry, stop, escalate, or pick an alternative path. 3, contract test. A contract test just verifies that the consumer and the provider agree on what the request and response should look like. In agentic systems, this matters a lot because without it, the agent might start guessing what an API response means. And guessing plus tool access is a bad combination. 4, auditability. After any agent action, you should be able to answer 4 questions. What did the agent see? What did it call? What did the tool return? Why did it decide to proceed? That's observability. And for agents, observability isn't just logs and metrics. It includes the prompts, the tool calls, the tool responses, and the decision the agent made based on all of that. And this is exactly why 2026 testing trends keep coming back to continuous quality, shift right, and stronger security and performance practices. Because when the system can take actions, the cost of an integration failure goes way up. That's called out directly in the X-Ray and White Test Lab 2026 trend articles. Now, let's talk about the leadership shift, because this is where a lot of QA engineers get stuck. If your first question when you see an agentic system is what UI do I test, you're going to struggle because a lot of these systems don't have a stable UI. The interface might just be a chat box, or there's no UI at all. It's a scheduled job running in the background. So quality leaders stop centering their strategy around screens and they start centering it around intent. What is this agent actually supposed to accomplish for the user and the business? Risk. What can go wrong and what does it actually cost when it does? Evidence. How do you prove it's safe and reliable? Governance. Which decisions need a human and what guardrails are in place? Same 4 pillars from episode 1. but now applied to a system that's making its own decisions. As the quality leader, here's what you're designing: the risk model, what must never happen, full stop. The guardrails, permissions, approvals, allow lists. The evaluation suite, repeatable scenarios that score task success, correctness, and policy compliance. An evaluation is basically a test set with scoring. And it's how you catch regressions when the model, prompts, or tools change. The release gates, what has to be true before this ships, the production signals, what you're watching after it goes live. That's the full picture. And execution, only QA only touches one of those, the evaluation suite, and only partially. Agentic workflows are not just automation, but smarter. They're systems that take real actions and that changes quality from UI verification to risk engineering. Your job isn't to click through screens anymore. It's to define the boundary, prove the system stays inside it, and own what happens when it doesn't. In episode 3, we're going into governance, how to design human in the loop checkpoints that actually work without slowing the business down, and how to prove compliance when the model changes underneath you. If you're done being the person who just runs tests and you're ready to be the person who defines what safe even means, subscribe. That's what this series is built for.